A self-landing booster and an upper stage that has a heat shield, aerodynamic surfaces, that skydives back down to the surface and lands. On top of that, Elon Musk and SpaceX are planning to mass-produce it at a scale never seen before in the rocket industry. 1,000 of them are supposed to be built in the coming years. It's the first evidence of Super Heavy serial number 1. A common dome sleeve. SpaceX is actively working towards that first prototype right now. Here's the second segment spotted on site. A Super Heavy LOX stack. It's a 4-ring segment made of 304L stainless steel. A large liquid oxygen tank on the bottom, a smaller methane tank on top, and a large downcomer pipe inside the LOX tank to connect the methane tank to the engines. Musk has already said that for a first booster hop, Super Heavy serial number 1 will only need 2 engines. Recently, SpaceX published a video of a vacuum-optimized Raptor engine doing its first test run without any trouble. The sheer force of the engine comes across very well in this video. Constructing the first Super Heavy should not take long at all. When asked by Tim Dodd about the differences of thickness between Starships and Super Heavy's rings, Elon replied, saying that the ship rings are thicker than they need to be for now. So, the same thickness works for the booster and the ship for hoop stress. The booster's lower tank will have longitudinal stiffers to prevent buckling. SN8 was rolled to the pad, SN8 of its rear body flaps attached. The flaps are now directly driven by electric motors with a gearbox, no more hydraulics. Elon furthermore tweeted that SN8's front flaps will be attached next week, with SN9 coming up next month. Now SN8's first flight will be to 15 kilometers or 50,000 feet. The SN7.1 test to destruction that we saw last week. Elon revealed some very useful information. He tweeted out the results of the pressure values that the test tank could hold before popping, saying that 8 bar differential in ullage and 9 bar at base due to propellant head. This is enough and improvements are in work. This number is possibly a little less than a lot of us expected, however the test was still a success. SN9 is apparently going to be completely constructed from the 304L stainless, and SpaceX are even making some tweaks to that mixture itself. So yes, not only did the tank reach the safety margin for crewed flights to orbit being 8.5 bar, but there are still many improvements that can be made to these vehicles.